Well, good evening. Welcome to Space Oddities. How is everybody? Hope everybody's okay out there in YouTube land. Thank you for joining us tonight. If it's your first time here, you are, of course, especially welcome. We're a bit thin on the ground tonight. It's holidays, people are doing various things, and Lou will be joining us hopefully a bit later, but he's had a last-minute meeting called on him, so he will hopefully be along a bit later. So I'm just left really with Daz and Roger, which is a cross I have to bear really. So
The Billy No Mates.
that's it. Anyway, we are a few in number, but the content is the same. So welcome.
Kevin says 3. That's a quorum. Is that a curry?
Yeah.
It is actually. Yeah.
Vegetarian.
Yeah, it's best had with pilau rice and a naan. Not my naan. But anyway. Derek, for a bit of fun, look up Flat Earth Dave. Quite entertaining. I will. Thank you, Derek. And Ian says 3 is the magic number. That's a song. Who did that song? 3 is the magic number.
3 is a magic number.
Who did that? No,
I don't know.
Perhaps somebody out there will tell us. Anyway, great to have everybody here. Want to give a special thank you to those of you who completed our readers' wives viewers survey last week. Yeah, old habits die hard. And
won't be seeing any of
that new segment.
Right, let's start this section again. Thank you to those of you who completed our viewers survey last week. Your views are much appreciated. We've cogitated and gurgitated, whatever. We've had a look at your views and thank you for expressing them, and we are taking notes as we go through them and analysing everything. It would be great if some more of you could complete the viewers survey. I'm actually just putting the link to the viewers survey in the chat now, and it won't take you long to complete because we only had 9 responses last week. We'd like some more because 9 isn't a very big number to make any decisions on or any analyses of. So if you wouldn't mind sparing us just a couple of minutes to complete the viewers survey, it won't take long, promise. And I think there are only 9 questions or something like that. So if you could do that, because your views are important to us and this is your channel and we want to listen to your views going forward and implement them if we can. So there we are. So and also you'll find the link to the viewers survey in the description of this video. So big thank you to Rother Valley Optics, our sponsor. Thank you to them for supporting us in this venture. And thank you to those of you who've been buying T-shirts. And unfortunately, last week, I forgot to give you the opportunity to buy us some coffee last week. So if you would like to buy us some coffee, the QR code is on the screen now. And any coffee you could spare us would be much appreciated. So yes, thank you, Roger. There we are. Roger's pointing it out to you. Scan the code up to where you need to go, and any help you can give us would be much appreciated. And also, don't forget that the T-shirts and hoodies are on sale. The Space Oddities T-shirts and hoodies. We're all wearing the T-shirt. You can't see mine very much, but hang on, there we are. It's definitely there. So if you'd like a Space Oddities T-shirt to be like us, obviously you want to be like us. So if you like that, the link to go to, I'll put this up on the screen as well. The Space Oddities T-shirts are there. A real bargain at £19, including UK postage and packing. Add £10 for foreign orders, and be the first on your block to have one of our magnificent Space Oddities T-shirts. And also the hoodies as well. The hoodies are £35, including UK postage and packing. They're really good quality. We can all vouch for the fact that T-shirts are good quality. Daz, you ordered a hoodie, haven't you?
Yeah, I've got a hoodie. Yeah, very good quality.
Yeah, and the hoodies are good as well. So you will find these links in the description of this video as well.
Yeah, because we got two designs of hoodie. We got the pullover type or the zip up ones. The pullover ones have the design on front. The zip up ones design on the back.
That's right. Just to make that clear, the pullover hoodies have got the design on the front, and the zipper ones have got the design on the back. for fairly obvious reasons. All right then, so what have we got for you tonight? Well, as we're a bit thin on the ground, I had to rustle a few things together for tonight. But of course, the man who knows everything about everything is going to give us our usual report on what's on the night sky. So, Roger, what's the sky up to?
Oh, well, it's up to being very cloudy and wet and windy, but I'm sure everybody knows about that in the UK.
Oh, it's summer then.
Yeah, usual.
Yeah.
So here we go for the end of July and into the 6th of July. It should be 6th of August. There.
Hey, you're going back in time, mate.
Yeah, that would be good.
Time travel.
That's when it was clear. That was when it was clear. Right.
Dr. Roger.
So this was the last time I saw the moon, back on the 25th, 6 days ago.
Fantastic.
And I had a rather clear view of almost the first quarter there. And that's turned out rather well. And on the same day earlier, I did some hydrogen alpha of the sun, which has got a little bit of activity on there, but I have noticed there is a lot more at the moment this week. But day after, I managed to get a few spots, and obviously we've got lots more spots on the go and producing some rather more activity on and around and outside of the surface. So
it's still fairly spotty, isn't it? Let's be honest.
Well, we've still got about another 12 months or so before maximum, so things are progressing nicely.
Well, actually, they're talking about the maximum could be the end of this year. We'll talk about that a bit later on.
Right. So, fortunately for everyone in the UK, it's cloudy, so we won't be seeing the full moon. Although tomorrow is the first of 2 super moons. Oh dear.
No. Away with your silly supermoons.
Silly supermoon, yeah. And you know, it's only like about 8 or 10% bigger, for goodness sake. So yeah.
By the way, Roger, Ian says, "What's the spotty one? Not seen that for ages."
Are you talking about the sun?
Well, or you're talking about Roger, Ian? Yeah, absolutely. He hasn't seen the sun, obviously.
No. So during the night sky, we've pretty much lost Mercury, Venus, and those planets there, but we've still got a good view of the Milky Way, the Milky Way core, summer triangle. That's all still nice, but we've also got, as this map is showing, from 11 o'clock, we've got Saturn coming up through. So as we progress through the night, Saturn will be followed closely by Jupiter, and that's something better to look at. Yes. So,
I can't wait.
Yeah, but fortunately enough, even though the moon is full and waning away later in the week, it is still quite low in the night sky, so it doesn't interfere too much if you're looking at Cygnus or other constellations.
If you're
like
in the
that.
UK, of course, here it's quite
if
high
you're
up
in
the sky.
Yeah, absolutely.
Never mind.
So yeah.
By the way, viewers, don't forget we've got the peak of the biggest meteor shower of the year. The Perseids coming up on the night of 12th, 13th of August. And this year there's no moon. So
there is no moon.
No moon. So if you've got clear skies for the Perseids peak night this year, it should be pretty good. And it's not often that we get a night for the peak where there's no moon. Sometimes, you know, I remember my dad taking me up to watch the Perseids peak night when there was a full moon high in the sky. And we sat in the middle of a park and, funny enough, didn't see one meteor. But it's going to be dark this year. So peak night of the Perseids, 12th, 13th of August. I don't know, because it alternates, doesn't it, really, between us getting the peak and the US getting the peak hour. I don't know about this year. But anyway, you know, when you're out...
Yes, I've got some information on that and 2 other meteor showers that are on the go at the moment.
Oh, great.
Yeah, you've got the Capricornids and the Aquarids.
Yeah. So there we are. So we've got Jupiter and Saturn coming back into the sky. They've been much.
Yeah, and we've got the moon up near it on Thursday, but nearish to Saturn.
Yeah. Oh yeah.
So yeah, but unfortunately Saturn is still a bit low in the sky for us again. But Jupiter makes up for it. So
I see you.
We've got the opposition of Saturn later on in the month.
Sure.
In October, August, and then December's opposition for Jupiter.
Yeah.
So there we go. I've just got this as a matter of interest. Venus is getting quite thin and quite bright, so it should be make a very interesting observation and photography, but it is quite close to the sun relatively. So you have to be very careful trying to point your telescope or other imaging equipment towards that area. But it should make for some interesting pictures with the crescent getting thinner and thinner through the week. I've inserted a picture of how thin the crescent is through the week over on the right hand side of these images as we go through.
That's pretty
and these are at 2 o'clock in the afternoon. So as the week progresses, it's still about the same height in the sky, but it gets closer to the sun, so it's almost trying to overtake it underneath, so to speak.
Sure.
But you can see the phases gradually getting thinner and thinner. And that's just in the last few next coming days. So it's making quite a big rapid change, and then obviously it will disappear, and then it will be a morning object again.
Sure.
Unfortunately, but yes, it should be quite a challenge. It's anything's a challenge at the moment with the skies that we've got. Yeah. And as you said, Andy, we've got the Alpha Capricornids, which are still on the go, but they're not quite as zenithial hourly rate as we have for the Aquariids or the Perseids. But there we go. So the Perseids is around about the 12th, 13th of August, and the Delta Aquariids are just about peaked at the moment, but we're all challenged with the weather, unfortunately. So we've got a few interesting images that we've had from the James.
Yes, I love this one.
From the James Webb, yes. And this is. Let me just get this. Let me just try and find the information I printed off.
This is the Herbig Haro object that looks like a question mark from a distance.
Yeah. So it's only 1,470 light years away in the Vela constellation. And yeah, so they've been trying to find PDS. I've got the right one. PDS. I've got them all muddled up now. So yeah, is
Hi Rachel, nice to see you've joined us. I hope you're doing well with Isaac.
So we got jets are crucial to star formation. Ejections regulate how much the stars ultimately gather. So we've obviously got some star formation in those two areas on the centre and on the right.
It's quite a frantic area of star formation.
Very frantic end.
Yeah.
Because there's the diffraction spikes. If you notice, they're actually red where the stars are.
Don't normally see that.
And yeah, so it's basically what it is they formed in their birthing clouds, in like you said, they're forming these jets. So yeah, very spectacular.
Yeah, I mean the left-hand side looks a bit similar in shape to the Sharkhead Nebula.
Yes.
Oh, okay.
If you're familiar with that.
Yes, I know that. Well, I've seen pictures of the Sharkhead. Yeah. I've never seen it myself.
And then we've got this one here, which is having a theory of water vapor forming around it, although there aren't any actual planets as such yet completely created from this disk.
They think that the water is in the form of ice crystals, and it's in the inner disk. And of course, the question is how can water survive without being boiled away so close to the star? And they think that there must be a lot of dust in that inner disk that is protecting the ice against being evaporated.
Yeah.
This is not the first time that we've seen water in a protoplanetary disk, but it is the first time it's been seen so close to the star.
Yeah.
So of course,
I mean, they're calculating it's only about 5.5 million years old, this star.
That's right. That's right. And of course, this was the one I was talking about last week, the one that's got two planets in the same orbit. And this was a further discovery about this object by the MIRI instrument on board the JWST this week. So this is hot off the press. One question, of course, that we need to answer is we don't know how the Earth acquired its water. So to find so much water in a disk of a young star will give us some clues as to perhaps what happened in the inner solar system. Might be the same thing, and this is where Earth got most of its water. But the question as to where Earth got most of its water is still, I think, an unanswered one. It's been suggested that it came from comets or asteroids, but nobody really knows. And I think the comet idea has gone out of favour now because of all the comets that we have spectroscopic analysis of. It's a different type of water to what's found on the Earth. So it's not likely that water was brought to the Earth in comets. But there we are.
Right. And then we've got this one, which is an interesting one of a spiral amongst billions of other galaxies here.
That's amazing, isn't it?
Yeah. I mean, it's almost like a mini-me just below the one that is in the foreground here.
Yeah. That's amazing.
Great, isn't it?
So I assume that is either a smaller galaxy or one of the same size further away. It's not a
one would assume so, yeah. Basing it on how things progress.
Yeah. Amazing.
So I shall now proceed to the gallery.
Ta-da! Thank you, viewers. As ever, we do love looking.
We've got a few images, as we do.
Yeah.
And this one, I believe, is a first from Keith Maslin.
Thank you, Keith.
North American Nebula in Cygnus with a Pelican as well, with an 8-inch Rasa Ioptron 770 and a Altair 26C one-shot camera. 6 hours over 6 nights.
Wow.
Wow. Could be. And here it is.
Oh my goodness me.
That.
That's amazing. That is beautiful.
Very good.
Well
Got
done.
some nice colours on there.
Beautiful palette, isn't it?
Yeah. The wall shown up rather nicely.
Yeah.
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 Yeah, you can see that very clearly, can't you?
Even
the ears.
Yeah. Okay, so
well done, Keith. Thank you very much for sending that in.
And our regular from Jerry Delay of the Wizard Nebula.
Wizard.
Oh, Wizard. If you can ever pick the wizard out from this nebula. It's not obvious to me, but apparently some people can. And here we are.
My goodness me, Jerry.
There we are.
Stop doing this, Jerry. just get better and better at this, Jerry. Goodness me.
I've yet to accomplish the wizard, so I shall have to.
He's on the. If you look, he's on the left-hand side at the top. If you look, you can see the pikey hat, but also you can see it's almost like he's got big, long, flared sleeves on. If you come down through it, and also there's another hand on the other side as well. Yeah, it just looks very, very spectacular. It's that is fantastic. Love the colour.
Yeah,
it's very beautiful, isn't it? It's absolutely stunning. Well done, Jerry. Thank you so much for that.
Okay.
So, Roger, you must be off soon.
It's him again.
Oh, God.
Oh, no.
Who let him in
off. Anyway, this one is a combination of the hydrogen alpha that I had in my first image, and I've now redone a second session with the O3. So
Right.
this is just 2 of the 3 narrowband filters I've put together, and I've got this.
Oh, Roger.
Whoa.
That's amazing.
I've sort of made a synthetic S2 filter by merging a part of one and part of the other to try and build up a color image like this. But there we go.
That's really spectacular.
Yeah, it's brought the wall out rather.
Yeah.
But I won't leave it on there too long because you might study it and see all the problems that I've got with it. But obviously, the more time on there, the better. I need more time on this, but
I don't see any problem there at all.
I'm getting there.
No, it's lovely.
Okay. Right. Okay. And
trouble is, now you've mentioned it, we're going to be looking for the flaws.
Yeah.
Yeah. Well, that won't take long. I'm quickly moving on. Right. So here's some of the other images that we've got of the sun in different wavelengths and filters and things that Daz wanted to show to compare how much activity there is around the surface and the corona there.
Yeah, the reason for it is this is today's image, and these there's 2 of them. If we stick with this one for a second, and they're from NOAA. That's the the American space weather people. Now you can go online and you can join them free, and they do all images like this. Now the reason I've put this up is that on the eastern side of the actual sun here, which is the left-hand side, you can see there's some very big areas of activity coming into play. Now, we were talking earlier about the maximum. Now, they were thinking the maximum would be round in 2025. But now they're predicting, because we're getting one of the indications they use is that when the sun's coming to its maximum in cycle 25 or any cycle, you get about 8 or 9 flares directed towards us at any time during the day. Now, excuse me, we've reached that peak already, and so now they're thinking that the peak of this cycle could be as early as the end of this year. But there's still some debate about it. But as you can see on the eastern side, there's some very big players that are coming in at the moment, and they're going to be giving us sending lots of flares towards us. On the 29th, there was a big flare which happened, which was directed towards us, immediately followed the next day by a smaller flare. And that will, if we've got clear skies tomorrow in the UK, set up your cameras, point them north, and then just take some long images, because there's a very, very good chance that we're going to be able to pick up aurora tomorrow, and maybe even on the 2nd, for the simple reason we've got that second little flare that popped off after it, which wasn't actually caught by NASA or NOAA because it was such a small flare. But it has been seen and it's coming in. So yeah, the reason I want to pop this up is, one, because there is a chance of aurora tomorrow night, and going on into the 2nd, and they reckon it's going to be here about 1 o'clock UTC, around about that time. But just get yourselves out there if you've got clear skies and give it a go. You may not be able to see anything, but your camera might be able to pick it out. And if we go on to the next one, Rog.
Right. Hang on. Whoa.
Oh, nice. That's so hard.
Right, this is a coronagraph. Again, this was this is today, and you can see it's actually been able to pick out a CME on the bottom there. It's all like about the 5 o'clock. On the, if you're looking at a clock face, about 5 o'clock, you can see the bulge of the CME, which is just being thrown out into space. Luckily, that's not directed at us, but we could still get some sort of like magnetic interference coming into the atmosphere from that. But yeah, I just wanted to show that what the sun is actually doing is really ramped up. It's going absolutely crazy at the moment, and the cycle, we do not know, because if the cycle does end this this year, it doesn't mean that we're going to then go down into the cycle's solar minima. We could actually end up maybe even having a double peak, so we may go back into another maximum a bit later on. Because if it does finish at the end of this year, we're only 3 or 4 years into this, because it was December, if I remember, it was December 2019 that this cycle started. And we were expecting, as I said, because they're supposed to be 11-year cycles, but they do vary quite a bit. The average is 11 years since we've been recording them. So it's either a case that we're going to have quite a long minimum, or we could have a completely short cycle altogether. Yeah. It's a science that it's, we just we're studying, we're learning more, as you'll find out a bit later on in one of Andy's little bits. Yeah, it's a fascinating thing to watch. And as I said, if you go online, you can find these apps. The Sun in Time is one of them. I think I've mentioned it before. And you can also go on, link up with NOAA, and look at their space weather site. So yeah.
Thanks, Daz.
I just thought I'd like to talk about that. So yeah.
Lou is going to deliver a presentation about the Sun's slightly unusual behaviour. But unfortunately, as I said, Lou's been called to a meeting, so he may not do it tonight. But if not, we'll definitely hold it back to next week. Because it's what the Sun is actually doing at the moment is a little bit unusual. It's an unusual solar cycle. Mm-hmm. So I hope Lou can, no pun intended, shed some light on it. Okay, let's move on. So what we're going to do now, we haven't had much news the last couple of weeks, so I've got quite a bit of news to get through tonight, viewers. So just give me a second to set this up. Now, this is a lovely photo of the SpaceX B9 booster being lowered by the mechanical arms known as the chopsticks onto the orbital launch mount for cryogenic testing. This is a photo from SpaceX. Lovely photo with a starry sky and the gleaming booster. The booster did actually go through all its cryo tests and seemingly perfectly without any problems. So I'll talk a bit more about that in a while. Who remembers this day?
Ooh, yeah.
This, of course, was the first orbital launch test on April the 20th this year of the Starship on top of Booster 9. And as we know, it didn't make it to orbit and had to be destroyed, but it was a big step forward. This was the biggest, most powerful rocket in history launching. And as you can see, it did get off the ground and lasted, I think about, how long was it into flight? I can't remember before they had to terminate it. But
I can't remember off
that. No, it's only a couple of minutes or so.
Yeah, just a few minutes. So that was that. Now, it was a fantastic launch. This was the launch you've just seen went into the history books. It's the most powerful rocket ever built. And if it had gone well, the Starship should have separated from the booster. The booster would have returned to the Earth, and the Starship would have gone into orbit. It didn't happen, but it was a good first try. Now, unfortunately, it did some damage. And look at this video. Keep your eye on the car. Hang on. Keep your eye on the car on the left. Sorry. This is a camera car from the NASA Spaceflight Media Organization. And keep your eye on the car. And And there was a lot of debris thrown about, as you can see. And this was the concrete from the underneath the rocket, which was meant to withstand it, but didn't. And just see that again. And there was a lot of damage, lots of concrete, some of it ending up in the ocean. This was the aftermath. As you can see, the launch mount itself was pretty much fried by the force and fury of those 33 Raptor engines, the most powerful rocket engines ever built. And you see the rebar from the concrete laying about there. In the background, you see the tanks of the orbital tank farm. They're all heavily dented by the flying concrete. The worst thing, though, happened directly under the orbital launch mount. This crater was dug. It was a sudden, unexpected mining because this crater was left underneath the rocket, completely destroying the ground underneath it, the concrete which SpaceX believed was going to withstand the force of those Raptor engines. The force of those Raptor engines is around 8,300 tons. So there was 8,300 tons of force bearing down on that concrete, and not surprisingly, it didn't survive. Now, of course, the big aim here is to get the energy of all of that blast away from the launch pad and dissipate it. So, does anybody like to guess, Daz or Roger, would like to guess how much energy was pumped onto that concrete in the blast? Any idea?
Ooh, do you want it tons per square inch or newtons?
Whatever units, fish per cubic centimetre.
I don't know. I'm just going to pick a number out of the way. 1,000 tons per square inch.
Yeah, well, I don't know about tons per square inch, but in terms of actual energy, the energy amount was 15 nuclear power stations output. So the equivalent of 15 nuclear power stations outputting their energy, that was what was directed downwards, which is an incredible amount of energy. And you've got to dissipate that somehow. You've got to get rid of it before it just destroys everything. So how does NASA actually do it? Well, NASA have these flame trenches which divert the flames away from the launch pad. And this seems a very good idea. But they also have a water deluge system. Here it is being tested. And NASA just this would normally be under the rocket because the rocket will come along on a track over this. So this will be under the rocket. And as you can see, they pump a lot of water upwards, not just to cool everything down, but to carry that energy around, because water is a very good absorber of energy. And there's a lot of water. In fact, if you want the exact figure, I worked it out at about 500,000 gallons or 1,892,000 litres of water in about a minute that they spray outwards at the launch pads at Cape Canaveral. So that's how NASA do it. But here, I think you can see the problem with digging these flame diverted trenches. The problem at Boca Chica in Texas, where SpaceX launched from, is that it's wetlands and the water table is just under the surface. They can't dig these trenches because they just get flooded immediately with water. So SpaceX have had to come up with another method for the next orbital test, which won't dig a hole under the concrete. And they've come up with something unique that's never been attempted before. Now, what they came up with the idea was having a massive steel plate, which is many, many centimeters thick, underneath the launch mount. And within that contains what is effectively a shower head, directing the water up at an angle away from the orbital launch mount to carry the energy away. And everybody, of course, said, no, that's never going to work. That can't possibly work. It involved building a network of huge tanks and pipes. The water is delivered via high-pressure gas behind it. So they had to build a tank farm for that to develop the nitrogen pressure behind the water to push it through the system. It's a really intricate network of pipes and tanks. And this was the steel plate when it was under construction in the workshop. And, and then it was wheeled out, and with the aid of 2 cranes, it was positioned underneath the launch pad. and put together and joined up to the piping. I have to say this took under 3 months from the time of the first attempted launch. And the fact that they've done all this in less than 3 months is nothing short of amazing. You cannot imagine any space agency, not NASA, not ESA, not ULA, not anybody, building something of this complexity in such short a time. Here's just some of the massive pipes that go into the whole system to carry the water. And last week they tested it for the first time, and here was the first test. And they did a half pressure test before this, but this was the first full test at full pressure. And that really is jetting out that water. We don't know how much water, SpaceX haven't specified, but at an incredible rate. And it seemed to work very well. And the hope is that it will withstand those 33 Raptor engines with their 15 nuclear power stations worth of energy, destroying the whole area again. And here's a lovely slow motion video, starts in slow motion anyway, from SpaceX themselves of this test. And as you can see, the water jets are diverted away from the launch mount to carry that energy away. But also, you don't want the water going straight up into the engines, obviously, because that's not going to do them any good and could well extinguish them. So this is a system designed to carry all that massive amount of energy away from the launch mount. Unfortunately, that's caused some problems because apparently SpaceX didn't apply for a permit to carry out that test. And under environmental law in Texas, if you dispose of any huge amount of water on the ground, you've got to apply for a license for it. And SpaceX didn't. And nobody's sure at the moment what the situation is, whether they will end up in court over it. But lots of environmental groups are calling foul. And there may well be a court case over it, which will delay the next launch, predictably. Also, the FAA on last Wednesday, I think it was, categorically stated there will be no launch of the Starship this summer because neither their own investigation into the near disaster of last time or SpaceX's own investigation are complete. So until the FAA issue the launch license, the Starship's not going anywhere. Personally, I think SpaceX will be lucky to launch this year, even though Elon Musk said it was definitely going to happen in August, using Elon time as always. But I don't think it's going to happen this year. Maybe late this year, early next year. But we're not going to see a launch out of Boca Chica until at least the autumn. Because there's another problem now as well. Because after the last launch, a group of environmental groups got together and took the FAA, the Federal Aviation Administration, who looks after the supervision of airspace, including rockets in the US, they gave the go-ahead to SpaceX for the launch. They gave them a license, and the environmental groups are saying they should never have done so. And they are taking the FAA to court, accusing them of not applying their own rules. And there was quite a variety of environmental groups involved in this. But now also, SpaceX have joined the FAA in fighting the lawsuit. They're co-defendants in this court case because obviously they need to support the FAA by saying, no, the FAA did make the right decisions. They did grant the license to us for the right reasons. So it's all in court and, it could go on forever. So it's a bit depressing, but there we are. Anyway, this was the PDS-70 star that Roger was talking about earlier, where they found the water in that inner ring. And as we said last week, if you remember, there's the planet, which is PDS-70b. There's what they think is a debris cloud, but they think it's a planet in the act of formation. And inside the inner ring, there's another gas giant. These are all gas giants, PDS-70c. And as we said earlier, they found water in the inner disk, which is quite surprising but exciting at the same time. Euclid has arrived at L2. The European Space Agency are breathing a sign of relief that the Euclid Dark Universe Telescope has arrived at L2, its destination, where it will start observing in a few months after it's carried out instrument calibration and checks and whatever. So we should start seeing some data from Euclid in a few months. It's on a mission to explore what's called the dark universe, that is to say dark matter and dark energy, about which we still know very little really. And if you don't know what L2 is, it's Lagrange point 2. It's at 1.5 million kilometers beyond the Earth. And it's a place where the gravity of the Earth, the Sun, and the Moon cancel each other out. So you can put a spacecraft there and it will remain there without having to use any fuel to keep maneuvering itself, because it's being pulled by the gravity, the Sun, and the Earth and Moon as well. And L2, as you can see in this diagram, we've got a few occupants of L2 at the moment. The James Webb Space Telescope is there, but also the incredible ESA Gaia spacecraft, which is mapping our galaxy, mapping billions of stars and making many fantastic discoveries. That's at L2 as well. And some people might think, well, isn't that a bit crowded? Because if you've got several telescopes there, won't they sort of be in danger of colliding? Well, I've got a lovely video to show you about the orbits of Gaia, the JWST, and Euclid. And this is what they look like. And as you can see, although the orbits do intersect in places, space is such a big place that these telescopes will never be in any danger of actually colliding. There we are. The Gaia telescope is in a really complex orbit that never quite repeats. And this has a strange name, which we'll see popping up on the screen in a moment. These telescopes are in no danger at all of ever colliding. And we hope for great things from Euclid to unravel these mysteries of what is dark matter, what is dark energy. And I'm hopeful that it will deliver results. So Gaia is in a type of orbit known as a Lissajous orbit, after Monsieur Lissajous. And as you can see, it's a really complex orbit. Now, I did actually try and look up and find out exactly what a Lissajous orbit is, because I'd never heard of it before. And this is what I got. So I think I'm going to ignore that, to be quite honest.
Well, that's pretty straightforward, Andy. What are you on about?
It's a complex orbit, and this is what you need to work it out. So hats off to the people who understand all that. But I think we'll pass over the Lissajous orbit, if you don't mind. Moving on.
It's a recipe for lemon pancakes.
Oh, that's what.
I've just noticed in the chat, Andy, Keith has said that the first test images are released today from Euclid, so I haven't seen that. So
I knew it was coming up. I didn't know it was today. Thank you.
Yeah, that's
brilliant.
Yeah, and also, can I just answer Graham Turvey's?
Do you want to go back?
No. This is going back to we're talking about sun cycles.
Oh, right.
Graham, if you look on our website and go to videos, there is a video called "Solar Activity, Volcanoes and Earthquakes, Are They Linked?" If you look at that, that explains the solar cycles for you, because that's what you were actually talking about.
Yes, we should. That's the channel, not the website. We don't have the website yet. Sorry.
Oh, sorry. Yeah, the channel. I do apologise. Yeah, I do apologise. So there is an explainer in there, and it's, as I said, it's called "Solar Activity, Volcanoes and Earthquakes, Are They Linked?" And that will explain. I'll give you a basic knowledge of the solar cycles and their history. So I just thought I'd like to pop that in there.
Thanks, So anyway, this is an archaeologist. No points for guessing there. What is this all about? Well, as you may know, the UK is building a spaceport at Saxavord in Shetland, and during the construction of the spaceport, they have found some really interesting Bronze Age remains. What they've found is a possible Bronze Age cremation, some polished quartz stones, and some granite blocks that must have taken many people to lift them there. And this is really interesting because the nearest Bronze Age remains of a similar age are actually on the mainland. I believe this is the first discovery of Bronze Age remains of this age on Shetland. So it'll be interesting to see what else turns up. So far, there's no word of it halting the construction of the spaceport. But the Saxavord spaceport hopes to be in use. When's the projected finish date for Saxavord, Daz, or what is it?
Well, it was supposed to be the end of this year, because they were hoping to do their first launch.
Yeah.
But But of course, with this, we don't know how long it's going to be held up. See, these archaeologists were already on site,
yes,
and they were recording the very ancient World War II bunkers that were on the site. So, and then this comes along. So,
yeah. There's no word of this holding up the construction, though. They haven't said so.
No, there's nothing in the write-up. No, nothing in the write-up, but we'll see.
So the spaceport is meant to be operational by the end of this year, and then Britain will have, for the first time, a launch capability, a vertical launch capability on its own soil. Remembering that Spaceport Cornwall, the ill-fated Virgin mission out of Spaceport Cornwall, was a horizontal launch, not a vertical launch. So this is all rather exciting. We'll keep you posted on what's going on at Saxavord, because it's really, really exciting. Anyway, next topic, understanding the boat. What on earth is the boat? The boat, as you might suspect, is an acronym, and it stands for the brightest of all time. Last October the 22nd, there was a gamma ray burst, which was the brightest one ever seen. And scientists have been trying to work out ever since why this gamma ray burst was so incredibly bright. Now, it's suspected that the majority of these gamma ray bursts, which are the biggest explosions in the universe, happen when a supermassive star collapses at the end of its life within a few seconds into a black hole, releasing huge amounts of energy, which is focused in the form of what's called a relativistic jet of material. And nobody could work out why this particular gamma ray burst was so bright. And scientists think they've figured it out now, because what they think happened was that as the black hole formed within the collapsing star, the jet punched out of the star, but it mixed a lot with the stellar material within the dying star. And this caused the jet to be encapsulated, if you like, contained within stellar material, which was blasted out along with the jet. And this is what made the brightest of all time gamma ray burst so bright. And when they've gone back and had a look at it, what they realized was that jet fortuitously was pointing right at the Earth, which is one of the reasons that if I just go back to look at this is it in cross section, this is the afterglow, and as you see, you've got the bright central jet, and then the material on the outside, which has come from the gaseous envelope of the dying star. So this was great, because it enables them to look back at similar gamma ray bursts and to see whether a similar thing has happened, because it's the first time this mixing of stellar material with the ultra heated plasma in the jet has been seen before. So that was that. Sad news for Voyager 2. If you're a fan of Voyager 2, it's lost contact with the Earth, and the mission control uploaded a series of commands, which all apparently were perfectly okay, but the effect was to get Voyager to tilt its high gain antenna, that big dish you see there, 2 degrees away from the Earth. And when you're at that distance, from literally outside the solar system, that is enough to lose communications altogether.
That's going to miss by miles, isn't it?
Yeah, exactly. Now, don't forget that the energy that's being received from Voyager 2, if you were to store all that energy up for 250,000 years, that energy would be enough to light a Christmas tree bulb for 1,000th of a second. That's how little energy is being received at the Earth. Because if you think of being outside the solar system and shining a torch back at the Earth, how wide is that beam going to be by the time it gets to the Earth? And because that beam is so wide, in effect, it covers nearly 3/4 of the solar system from where Voyager is. So the Earth receives a tiny, tiny fraction of, I think isn't it only a 15-watt transmitter that's on Voyager, if I remember rightly, something like that.
Nothing great.
Yeah, it's not very much at all. Yeah.
So this is why NASA had to extend the dishes of the Deep Space Network, of which there are 3 around the world, and one of them's here in Spain, actually near Madrid. And they've had to build extensions on the dishes just to catch some more of that tiny signal. All is not lost, though. If you're thinking Voyager's lost and it's game over, no, it's not, because luckily Voyager is programmed every few months to realign itself with the Earth automatically, just in case a problem like this has happened. And the next realignment of its dish antenna is scheduled for October the 15th. No, sorry, October the 26th. So on October the 26th, the spacecraft will reacquire the Earth, and we should start receiving data again and be able to communicate with it. Don't forget that the Voyagers are our first interstellar spacecraft. They are beyond the solar system and well past their sell-by date. They were launched in 1977, and we're still receiving useful and valuable scientific information about the interstellar medium from both the Voyagers.
Yeah, it's not the first time we've lost contact.
No, it isn't, and it probably won't be the
Voyager 2.
last.
Yeah, no.
Most of the Voyager instruments were turned off a long time ago to save power, like the cameras, for example. But it's still doing useful science out there beyond the solar system.
Yeah, because they're still looking into ways that they can actually turn things off or rearrange, reconfigure things.
Yeah.
They're trying to stretch it out so it lasts till 2025, and then that'll be its 50th year.
That's right. That's right. Anyway, moving on. One of the biggest mysteries in solar physics has always been that the corona, the outer atmosphere of the sun, is so much hotter than the surface of the sun, which is not logical. The surface of the sun is about 6,000 degrees, but the temperature of the corona, the outer atmosphere of the sun, is about 1.8 million degrees. And solar physicists have never understood why this is. What is heating the solar corona to such an extent? They think they may have found the answer, courtesy of the European Solar Orbiter, a spacecraft that's orbiting the sun, as its name says, studying the sun close up. And if you look at this, what are we seeing here? These are magnetic waves racing across the surface of the sun. And you can see them very clearly here. They're color-coded on the right, on the insets on the right. And what scientists think happens that these magnetic waves, as they're roiling across the surface of the sun, are responsible for heating the corona to such an extent, although the exact mechanism still has to be worked out. But they think that this is the reason. Finally, we know the reason why the sun's corona is so much hotter than the surface of the sun, because of these newly discovered magnetic waves on the surface. Now, here's an interesting one. There's this white dwarf, you see. It's been nicknamed Janus. It's not an official name. Janus has got one hemisphere that's hydrogen on its surface, and the other hemisphere is helium. So there's this distinct line between a hydrogen surface and a helium surface. This is truly bizarre. Now, it's known that a lot, but not all white dwarfs do go through a period where the surface changes from being hydrogen dominated to helium dominated as the white dwarf gets older. But it should happen uniformly over the whole of the star at the same time. Why on earth has this white dwarf got two distinct hemispheres, one hydrogen and one helium? And what led them to examine this was the fact that they could see that the brightness of the white dwarf was changing as it rotated, which didn't make any sense. What was causing that brighter magnitude? And it was simply the fact that the helium surface is so much brighter than the hydrogen hemisphere. This is a really bizarre one that nobody understands yet. It's really, really strange. Talking of strange, this is a strange object. Now, you may have heard of fast radio bursts, these enigmatic emissions of radio waves that last a few milliseconds normally from all over the sky, several times a day. We don't know what causes them. They output enormous energy. One of these fast radio bursts can output radio wavelengths more energy in a few milliseconds than the sun does in an entire year at all wavelengths. And now they found a really, really strange object that doesn't appear to fit the explanation for anything known. So let me just go through this with you. It's an object called GPM J1839. It's 10. It's 15,000 light years from the Earth, and here's an explanation. No, it isn't. Oh, okay. Doesn't appear to work, but never mind. So what we think causes a lot of these fast radio bursts are magnetars, which are these super magnetized neutron stars These have got a magnetic field so strong that they could pull the keys from your pocket from as far away as the moon. And if you got to within about 600 miles of one of these neutron stars, your body would dissolve because of the strong magnetic field just tearing your atoms apart, basically. They're not very nice. But this one is bizarre. Why? Because every 22 minutes, it emits a radio burst that lasts 5 seconds. Sorry, 5 minutes, not 5 seconds. The longest radio burst seen. And the rotation period of this does actually turn out at 22 minutes. So every 22 minutes, it flashes radio waves at the Earth for 5 minutes and then repeats. Nothing like this has ever been seen before. It's not a magnetar because this thing is rotating far too slowly for it to be a magnetar, which rotates at incredible speeds. It's been suggested it's a white dwarf, but it doesn't really seem to fit that description either. To have something flashing these radio waves every 22 minutes for 5 minutes is just absolutely crazy. Why hasn't this been seen before? Well, because basically nobody was looking for it. And they've looked back in the data once they'd realized what was going on here, and they realized that they've got radio astronomy records of this going back to 1988. So it's been going a good few decades at least. So what this object is, nobody knows. It's a complete mystery. A lot of this has been carried out by the International Center for Radio Astronomy Research. This is an organization that was set up to basically process the data from the Australian arm of the huge radio telescope that's going to be built there. And there's a new radio telescope 1,000 times more sensitive than any ever built, being built in Australia and South Africa. It's called the Square Kilometre Array. It's a square kilometre of antennas operating at various wavelengths. So the high frequency antennas are going to be in South Africa and a couple of other African countries. The lower medium frequency arrays are going to be in Western Australia at a place called the Murchison Wide Array. And there we are. This is what I was referring to.
In 2021, we made a surprising discovery. We found a radio source that repeated every 18 minutes, shone for 3 months, and then vanished completely. Since this was unlike anything we'd seen before, we began searching for more, scanning our Milky Way every other night with the Murchison Wide Array. In July 2022, we found another signal in a different part of the sky, repeating every 21 minutes. It lies over 15,000 light years away, in the Sputum constellation. To understand it better, we used telescopes from around the world, observing at different frequencies and recording the pulses in high time resolution. What we found was amazing. This source seems to have a strong magnetic field and rotates, producing pulses each lasting up to 5 minutes. But how do we explain this? Neutron stars with extreme magnetic fields are called magnetars. While their magnetic fields twist and untwist and their rotation rate slows, they can generate radio emission for a few months to years. However, our new source has been active for much longer. We searched archives of data going back 30 years and found that it had been active since at least 1988. It was there in the data, waiting to be found all this time. Using over 30 years of data, we calculated that the source is barely slowing down at all. Even using very complicated magnetic field models, our theories struggle to explain how it can produce such bright radio emission for so long. Fortunately, the source is still active, so astronomers around the world can work together, make new observations, and eventually understand this fascinating phenomenon.
So there we are. So that's basically what I was saying, that they're completely stumped. And if you look on the left here, at the bottom of this trace, you can see there was some radio astronomy data from 1988, but as the technology improved, the reception of those signals improved, and you can see very clearly the regularity of those traces on each date. this is a bizarre object for which, as the lady said in the video, we're struggling to explain exactly what it is. It's always fantastic in astronomy when we discover a new type of object that we haven't seen before, the sort of who ordered that object. So there we are. Okay, just a few quickies to finish. NASA have got a new website. They've completely redone their website. It looks wonderful. It's a lot more comprehensive and easy to use than the previous one. If you want to try it out, it's not finished yet, but you can try out the beta version, which I've been doing, at beta.nasa.gov. Also, later in the year, NASA are releasing a new app called NASA Plus. This is a streaming app which will allow you to plug into NASA and stream all their videos and live TV and everything at NASA in terms of multimedia. As I said, it's called NASA Plus, the universe at your fingertips. It'll be available across all platforms, Apple, Android, PC, everything. And it looks as though it's going to be really good. And well done, NASA, for putting this together. So go to beta.nasa.gov to try out the new website. Let us know what you think. Email as always at spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. Also, starting tomorrow, the International Science Film Festival. If you want to see some great films online about science, it starts tomorrow, runs in all of August. Go to cinema.org.au. I put that in the description of the video, and looks like there's going to be some fantastic films. Looking forward to this immensely, the International Science Film Festival. Basically, you register and they will send you a link on how to access the films. And that's it as far as that goes. So that's the news. So what do you think about all that?
Yeah.
Some interesting stuff, isn't there?
Yeah, it was interesting stuff. I mean, you mentioned that two-faced star, as they call it.
Yeah.
And that's how it's got its name. It's down to the Roman god Janus, which is which has two faces. Well, of course, also Janus, or whatever you want to call it, Janus, was a share ride probe that was to go with Psyche to when Psyche was going to go off to have a look at it. To have a look at Psyche, the asteroid, to see whether it was worth mining and what it was made of.
Yeah.
But because of all the delays that have gone on, apparently Janus has now got nowhere to go, so it's had to be mothballed. So if anybody wants a probe for anything, there's one going cheap at NASA.
No,
so unfortunately, it's had to be mothballed until they can find a target for it.
Okay,
and hello, Lou.
Thank you for joining us, Lou. How was your meeting? Yeah, we can't hear you, Lou. No, still can't hear you. Oh dear. Okay. So
book, film, or play. 3 syllables.
Yep. the whole thing.
Not that.
Hey,
that's it. Yeah.
One button away, just one away. I have fewer than 15 meetings this week, so it's a slow week, and life is good.
Life is good. Glad to hear it. So you've got you wanted to tell us about your visit to Baton Rouge, I understand.
Oh yes.
Okay. Well, what we'll do, we'll come back to that, because next Daz is going to tell us all about what a blue moon is. So here's this from Daz.
Or is it?
Is that playing?
Yeah, it's playing, but it's moving, but yeah. It's just starting.
In modern usage, has nothing to do with the actual colour of the moon.
It's a bit glitchy, Andy.
Okay. I think we'll come back to that, Daz.
Although a visually blue moon.
I think we'll come back to that because it doesn't
Yeah.
explain very well. I'll have to examine that. So, Lou, what was going on at Baton Rouge?
Well, if anyone who is an amateur astronomer, I imagine we have lots of those in our audience, and perhaps even if you're not, you know about the annual ALCON meeting. This is the Astronomical League's annual conference. And the Astronomical League is a umbrella organization. I think it has over 300 amateur astronomy clubs, mostly around the United States, under its umbrella. And every year they get together somewhere in the country to share stories and learn about telescopes and hear fascinating new discoveries of the cosmos. And it hasn't been so well attended because of COVID in recent years, but I think they kind of came out of the COVID cloud last year, and I went this year. And it was held in Baton Rouge, Louisiana. So lots of great Cajun food. Shrimp and grits with every meal you have, including breakfast. And it was very interesting. And I wanted to just walk you through some of the people who were there, some of the talks that were given. I didn't do video this time because we've had some problems with video in the past. So these are just slides. Let me walk you through it.
Oh, lovely.
There we go. So it was at the Hilton Baton Rouge, a very old hotel. In fact, it's so old that in the bar area, in the bar restaurant area, you kind of scan around and you see this set of bookshelves. And what you don't know is you can open one of the bookshelves, you can peel it away from the wall and go down this secret stairway into a place where they had speakeasies during the Prohibition years in the 1920s in the United States. Yes.
How fantastic.
And it's very comfortable and loungy. They usually let us stay down there for about 20 or 30 minutes till they found out we were there, and then they ushered us back up. So a very nice old hotel, very tall ceilings, very majestic. And there I am. It says where to go once you get into the lobby. So I arrived and I knew where to go after I deposited my luggage in the room. And here's the friendly intake people who had my badge for me and all of the things I'd signed up for. There were various tours of an observatory, a local observatory. They had a 36-inch fork-mounted telescope. Oh my God. And so that was pretty cool. They had a tour of the LIGO facility. That's in Baton Rouge.
No, really?
Really. I didn't go on that. I didn't arrive in time for that, unfortunately. But it's just 2 hallways, right? So it's no big deal.
Yeah, just two tunnels.
And a planetarium show. And so there are always interesting things to do. Let's see here. There we go. Whoops, let me go back. Okay. And so the league is really good about getting excellent speakers to come and talk. And even if you aren't into amateur astronomy, you probably know some of these names. David Levy was there, right?
Oh, wow.
The co-discoverer of Shoemaker-Levy 9. And I'll talk about David in a minute. He gave just the most amazing presentation. Fred Espinec, Mr. Eclipse himself, was there. It was great connecting up with Fred again. And so many other people that amateur astronomers know, and planetary scientists, such as Brother Guy Consolmagno, I think is how he pronounces his last name. I didn't even know he came to these things. I see him at Division for Planetary Science conferences each year. But he was there giving a talk about his book. So lots of great speakers. And I mentioned the tours before. So you see, it was a LIGO tour, Louisiana State University Physics and Astronomy Department tour, the Highland Park Observatory, which had the 36-inch, and that was co-located or co-hosted with what they call a starbecue. This was barbecue under the stars, which I foolishly signed up for as a vegetarian. But live and learn. They had the rice was great, and but they have a very nice facility there. And as we got off the bus, the thing that I remember most is that there's a woman standing just outside the bus with 3 big bottles of insect repellent. And she said, "Now you don't want to get bitten by the mosquitoes." I said, "I don't feel any mosquitoes. I don't see any." She said, "Well, they'll come out, and they're about as big as sparrows." We all, at that point, we all went madly for the insect repellent. Okay. So I mentioned David Levy was there, and he gave the most impassioned, beautiful speech I think I have ever heard. And the part of the reason for that, besides the fact that his life is interesting and the work that he does is fascinating, is that he dedicated his presentation to his wife, Wendy, who had passed away just a few months ago. And clearly David is still, heartbroken. So Wendy went with David on his observing runs and was a true astronomy partner for David. So we got to kind of, those of us who knew Wendy, we kind of had a chance to say goodbye. And then he gave a talk about his life, how he got interested in astronomy, and how he started observing comets, and spent a fair amount of time at the end talking about, of course, comet Shoemaker-Levy 9. And he showed some very interesting images of the comet after it had broken up, and talked a little bit about how they discovered it and when they realized, whoa, wait a minute, is this going to collide with Jupiter? And they checked their numbers, they checked their ephemeris, and absolutely. So that's when the whole world got involved. And for those of you who were interested in all of this back when Shoemaker-Levy 9 hit Jupiter, every telescope on Earth and beyond was pointed at Jupiter to get images of this amazing feat. And there were bets going on about what would splash up from the atmosphere of Jupiter, what materials would splash up out of the upper atmosphere. It was just a very exciting time. And the league, after his talk, gave him a Lifetime Achievement Award.
Oh, great.
So that was really nice.
Lovely.
David was asked once to describe comets. And after a long pause, as he tells the story, he said they're like cats. They have tails and they do precisely what they want. And
brilliant. I love that.
All of you comet observers out there know that's absolutely true. We get excited about these things. We hope they do one thing, they do another. So he had that printed on a bag, and that is a direct David Levy quote.
That's brilliant. I want one of those.
I'll see if I can get one. David and I agreed that we'd keep in touch a little more often.
Fantastic.
So just a picture that, there are many people there. That's David on the right. That's a better picture of David, I think. That's Carol Eorg in the middle. And Carol is, I guess he's the past president of the Astronomical League. But he was MC for many of the talks and many of the events. And on the left is Judith, and I forget her last name, but I think she's from the local Baton Rouge club and was there kind of manning the tables where they sell things and just keeping the conference going. Well, no Alcon meeting would be complete without Fred Espenek. And so Fred came out in person, and here we are in the Baton Rouge Planetarium, and he is giving a talk about, take a wild guess what Fred talked about.
Could it be eclipses by any chance?
My goodness, you're right. No surprise to any of us. And the presentation was really cool because he he talked about, say, maybe the last 150 years or so of eclipse watching, and he pulled out quotes from various people who had been viewing eclipses and had them read by, kind of a storyteller. So it was as though you were hearing these quotes about eclipses in real time.
Oh, lovely.
That was exciting.
Can you imagine?
And he played, of course, some of the videos of his eclipse viewing. And in one case, I think he said he had something like 14 cameras set up to view the eclipse, 3 or 4 on telescopes and others that were scanning the horizon. And he talked about a technique that I hadn't really thought of. He said, what you want to do is you get your cell phone and just put it on the ground behind you somewhere so that you can see the horizon and you can see the sun above in some wide angle sense, and just let it run. And what you'll see the environment get darker. You'll hear people talking. You'll hear people screaming. You'll hear the snapping of cameras, and it really adds to the experience. So, just a little tip from Fred Espenek. So got to connect with Fred again, and it was nice to see him after. We only see each other at conferences these days, so that was nice. Here we are in the planetarium. Let's see, you'll recognize on the right here, that's Scott Roberts, the president, I guess, of Explore Scientific. And I'll show you a picture of Scott with his telescope a little bit later. Scott's company, Explore Scientific, was a sponsor of Alcon this year, and I couldn't believe it. He gave away 2 5-inch ED Apo refractors, the latest design, the latest, greatest, best design that he has, on excellent go-to mounts as prizes to some of the students who presented and who presented their research, some of the student prizes. So that was very generous of Scott.
Lovely.
Yeah. After his talk, Fred came outside of the planetarium and was selling some of his books. And I bought a couple of them, and I said, do you take plastic? And Fred said, no, I don't do this enough to take plastic. So he just handed me the books. He said, I know where to find you. So I mailed them up.
We know what you live. Isn't that nice? What a gentleman, eh?
Yeah, absolutely. I mean, and he signed the books. So that was nice. So let's see here. Okay. This is David Ecker, I think. The
we have met him before. He was a guest on Astro Radio.
Excellent.
Yeah.
Astronomy Magazine. And David's passion, his research passion, is galaxies. And he gave a wonderful, in-depth talk about galaxies. In fact, it was so great that I couldn't, I had to divide my time between listening to him and trying to type with my thumbs on my cell phone questions I had for him about galactic evolution and gas pore, ellipticals, and all kinds of things. And he was very kind to spend some time with me after the talk to answer my questions. But he's a great speaker, very energized. And this picture in the lower right, this is a picture taken in 1923. I think.
Isn't that one of Hubble's?
Yes, it is. It is the famous picture of the Andromeda, at the time Andromeda Nebula, now Andromeda Galaxy, where he realized that there is a Cepheid variable in the galaxy. And at the time, the universe was thought to be about 100,000 light years in diameter. And when Hubble did his calculations based on this Cepheid variable, he came up with a number of 1 million light years. So many at the time said this has to be wrong. Redo your calculations. Of course, it was wrong, but it was wrong because it was too light. The distance to the Andromeda Galaxy is 2.5 million light years. But it was important because it addressed the holy grail issue of the time. Do we have one galaxy and that's it, or are there many galaxies? So that's a very famous image.
Sure, sure.
This is, let me think. It's right there. I put it there because I couldn't remember. Donna Moran. She's with the International Dark Sky Association. What a great, all the presentations were great. She showed pictures of intersections where there had been car crashes and how the glare from all the lights made it impossible to see this person going across or that person. She talked about the health impact of having too much light at night. There is very clear evidence. You guys, I'm not a doctor. Look it up on your own. But listening to her talk, increases in prostate cancer, colon cancer, breast cancer from people sleeping in rooms with too much light coming in, especially light that kind of tends toward the blue end of the spectrum. So for those of you who know the IDA, they lobby local governments to have them put full cutoff lighting in their cities so that we can see the night sky again. And there are obviously a number of other benefits to doing that. Yeah. So here's Scott Roberts, and there's the telescope and mount that he donated to these amazing students who gave presentations on their research. And I couldn't follow some. They were talking about the questions they had or came up with about the standard model of physics and boson fermion incongruencies. And I thought, well, okay, I'll look that up later. But so that was very impressive. And I couldn't, with all of that generosity, I couldn't leave without buying a few things from him. So
No, of course.
Put my orders in.
It's the proper thing to do.
Yes. Each Alcon meeting is ended in gala fashion with a large dinner where lots of awards are handed out. I mentioned some of them are student awards and lifetime achievement awards and just awards for things that for education and public outreach and for lifetime support of the league and so on. And this was, I guess, the speakers table. And so that's David on the left, Pranvera Hassani, who is the president of the Kosovo Astronomy Club.
Right.
And she was there and was on a panel discussion on education and public outreach. And then over on the far right is Carol Eorg and his wife. And the food wasn't that bad, actually. It was pretty good.
Good. That's what you want. It's all about the food. Yes,
no barbecue. There was no barbecue, so that was a real treat.
Right.
So that's that's my experience. I got there a little bit late to attend all of the tours, but it was a great meeting. And the next meeting, for those of you who want to go to Alcon, will be in Kansas City, in the United States. I know that's a bit far afield for you and the guys in the UK, but it was a great meeting.
Great, thank you very much, Lou. That's fantastic.
Yeah, because most of those people you were just talking about, of course, we've interviewed on Astro Radio.
Yeah, we've had them on.
We've had Scott on there. Was he there with his was it Dreamline caravan or whatever they call it, Streamline or whatever?
Streamliner, yeah.
He's famous for his Streamline. Of course, David. I was sad to hear about Wendy.
Yeah.
He came on. He was a great guest, and both he and Wendy recited a poem at the end. So it was very sad to hear about Wendy.
It might have been that he recited a poem that was one of Wendy's favorites, I think, at the conference. So maybe that was one.
Yeah, he was a lovely guest. Well, in fact, all of them were. Plus David as well from Astronomy magazine, and then of course we had the lady from Kosovo, also Prank. What's her name? Sorry, I know her as Pranky because that's what her Instagram name is.
Pranvera Hassan.
Yeah, because I
think that's how you.
Yeah, because she's a great advocate for astronomy, as you said, in Kosovo, She's got a very interesting life story as well. What happened to her during the Balkan War and things like that in her family. And of course, she's trying to get an observatory built there as well, isn't she? So yeah. So most of those people we've spoken to and we know sort of thing. So yeah.
Okay, thank you.
Quickly, I had a short conversation with David, and he's quite interested in putting kind of promoting our show through their website, which has about 100.
Thank you.
Over 1.5 million viewers. So you perhaps
How many?
Million and a half. More than we have.
Yeah, we'll make him famous. We'll make him famous.
I thought you said 1.5 viewers. I thought, oh well, better too many than too few. Thank you, Lou. That was fantastic. Talking of astronomical events, this year's autumn meeting of the British Astronomical Association takes place in the city of Leicester. And you can find all the details on their website, which is britastro.org.uk, britastro.org.uk. And there's some good stuff going on, as ever, aimed at practical astronomy at the BAA meeting in the autumn. So there we are. What else? Anything else? I can't think of anything else at the moment. Yes, just one final thing. I'm just going to put the link to the viewers survey and the International Science Film Festival in the chat. If you would be so good as to just fill out the viewers survey, because as I said, we didn't really get enough responses last week to come to any conclusions or do any meaningful analysis about what we should be doing with the channel, what you would like us to do, what you would like us to stop doing, if anything. So you've got the link there to the International Science Film Festival, which starts tomorrow. So register and they will send you a link to watch all the films online. And then you've got the link to the viewers survey. Both of those are in the description of the video as well. So it just remains for me to thank Daz and to thank Roger and to thank Lou for being here tonight. We are a bit light on the ground tonight, but it is the summer and holidays and all sorts of stuff. So we hope to be more densely populated here at Space Oddities next week. Thank you again to Rother Valley Optics for supporting us in this little venture. We thank you, especially the viewers, for being here. And Kuhn, it's been lovely to see you here, and I hope you come back, basically. And we hope you all have a fantastic week. Thank you all for your support. And don't forget, next week on the 7th of August, our very special guest will be the Angry Astronaut. You may be familiar with his YouTube channel. He was meant to be joining us a few weeks ago, but unfortunately he had food poisoning, so he couldn't make it. But he will be with us next week. And if you know his YouTube channel, you'll know he's a fascinating guy. And we'll be chatting to the Angry Astronaut, aka Jordan Wright, next week here on Space Oddities. So we'll look forward to that. On the 21st of August, we have the astronaut Scott Poteet, who will be joining us. Unfortunately, because of a family bereavement, Scott couldn't be with us when he was meant to last time. And he will be joining us. And Scott, as you might know by now, Scott will be the pilot of the forthcoming Polaris Dawn mission. And the details for that will be on the website and in our Facebook page. So we hope you will join us on the 21st of August to greet Scott Poteet, the pilot of the forthcoming Polaris Dawn mission. So from all of us here at Space Oddities, we hope you have a fantastic week. Say goodbye, guys.
Goodbye, guys.
Goodbye, guys.
Bye, guys. Thanks for being here. Have a fantastic week. Take care of yourselves. Look after each other. And we'll see you again soon on Space Oddities.
Yeah. Keep looking up.
Bye-bye.
Yeah. At the clouds.
At the clouds. Not here. No clouds here. So